Functions, grades 9 through 12. It's an NCTM publication. And
it's a goodie.
Excuse me?
It's a good one.
Yeah. And it goes through functions talking about what, looking at essentials and big ideas. So, for example, the big idea they say first is the function concept. So what is a function? How would you define it? How would you define function? Anybody? Because the book gives about 10 different ways you could define a function. So even middle school.
Ours is when you have X, you're only going to get one result.
Okay.
Whatever happens to X only results in one result.
Yeah.
The function is what the rule that is applied to X that gives you only one result.
Right. So it's more you're talking more input output, and for each X there's only one Y. Okay. For even with my college kids, they actually liked the example of everybody has one birthday. You know, everybody has one birthday, so for each X there's only one Y. And that also takes into account the fact that when we say, okay, this is my birthday, but it could be several other people's birthdays. So for example, in my family, we have 3 cousins that have the same birthday. So we can see that mapping, they can visualize it. Now, of course, this year I had a woman who said, I have 2 birthdays. And so, yes, of course.
That'll wake him up, won't it?
Yeah, you know, darn. But anyway, she was adopted, and so her mother says it's one day, and the father says it's a different day. But yeah, I know. You can't get a perfect example. But for the most part, students really grabbed onto that. But there's also that idea, as you said, one X and one Y. All right. So those are some things we might say, and there's many variations of that. But I think the singular thing that keeps running through kids' heads is that for each X, there's one Y. All right, so it's the single valued mapping. We apply to a wide range of situations. I often talk about when you work, you get paid so much per hour. If you work 10 hours this week and you got this amount in your paycheck, and you worked 10 hours last week and it was a different amount, do you think there might be a problem?
There's a problem.
Yes, there's a problem. Okay, so we're looking at that. How about this one though? Domain and range don't have to be numbers. What are you saying, Todd?
Transformational geometry.
Yes, transformational geometry falls in there. Also matrices. For example, you could find determinants of a matrix. Okay, so in that case, the range would be a number. They're saying matrices being a domain, even though we would think that's numbers too. Okay, so their big idea number 2 is the covariation and rate of change. We talked about that a little bit, the proportional reasoning. We're looking at how the relationships change as we look at difference in X's, difference in Y's. We also look at how the variables and the function's rate of change. So we can look at that in terms of linear functions. We can look at it in terms of quadratics. And so that's a big piece of what we're talking about with the functions and looking at how they change. The graphs of functions. Well, vertical line test. I know my students feel, if you can do the vertical line test, that's it. But does that work for all functions? Can you think of a function where this might not work? Well, of course, we have Todd in the back, but we like some
quadratic.
We have people in the front.
Quadratic equation where it's X equals Y squared minus 1.
Okay.
It puts it sideways rather than up and down.
Right. And is that then a function?
It's a function of what, Y?
Yeah, well, we might have to think about whether we're going to limit the range of that function to get that 1x to 1y. Yeah, looking at, so it's the C
right.
to the side. Okay, so we'd have to limit the range to have it fit that definition of function. Yeah.
Could we have a horizontal line test for that situation? I'm sorry, this is what mathematicians
well,
do.
that would you just rotated your graph, so then you rotate your vertical line to horizontal, right?
Yeah, and that gives us an increase. And for that one, whatever, which is kind of part of this, but the idea for horizontal line test, what I tell students is for every ticket, there should be one seat, and for every seat, there should be one ticket, right?
That's
And
great.
sitting someone on your lap, okay? Hopefully, depends on who he is.
Maybe.
Yes, it depends, you're right, you're right. Well, some of the example